Welcome back, guys. Are we in? Are we live? Are we live? Streaming. Are we live, guys? Are we live? Are we live? Are we live? Are we live? Checking the audio. Right, here's our question paper here. Is our audio fine before we start? Let me check it very quickly. All right, the audio is fine, people. Where are the people? Where are the people? There's only 6 people here. Right, I only see 6 people. Right, people? Oh, yes. Oh, Velase said yes. Where are the people? Right, come back, people. Come back. Remember, we have to do trigonometry. So this is question 2 of trigonometry. Let me zoom it very quickly, guys, so that everyone can see. But this is another question paper. I just went to my archives and I find this one here. It was very interesting. So I'm just gonna zoom only on question 2, which is trigonometry there, right? You guys see this question 2 here, right? I think yes, this is visible. Now this question 2, we have question 2.1.1, question 2.1.2, question 2.1.3, and question 2.1.4. I hope you guys are ready because I managed to take some snack so that I don't allow fatigue to do what it did to me last time. Right, so we will do this question 2 here. Right, let's start, people. I can see people are here, and some people probably they are sleeping already, but it's no time to sleep. We have to pass this mathematics thing here, right? Right, now let's look at 2.1.1. Now, this one here, they want you to determine sine 105 minus sine 15 without the use of the calculator. Do you guys see this question here? There we go. And this question is 5 marks there, guys. Usually, they only give us one trigonometric ratio with these angles, right? We have done something similar to this yesterday, so let's just do it. Let me zoom out and let me write it where there is space, guys. Right, there we go. I'm gonna write it here, guys. I'm gonna write it here where there is space. So you are given the following, guys. You are given sine 105 degrees minus sine 15. Right, and remember, they want you not to use a calculator, my good people. So what you need to do here, you need to know the triangles, guys. We did establish those triangles earlier. So let me try to draw them. Guys, you need to know these triangles, right? I know them because I've been teaching this for some time. So you also need to find a way to know them. So we have this one here of 30 and 60, guys, right? So this one here, we can write 60 here, and then this one here we can say 30, guys, right? And then first remember, this is supposed to be 2 and that is supposed to be 1, and that is root 3, right? So this is one of the triangles because they contain special angles and they will help you not to use a calculator, by the way. And then we have the second one here. This one is simple, guys. It's the one of 45, right? Special angle, which is 45 for both of them. So we have 45 for this one. Oh, I hope you can see. Doesn't look so good. Let me try to write 45. Must fit here, guys, right? I hope you can see. And then this other one is also 45. And then we know that this side is going to be 1. It's going to be 1. And the longest side is going to be root 2. Unfortunately, these triangles here, guys, they are not there on the formula sheet. And remember, guys, you need to have your formula sheet with you ready, right? Make sure you have your formula sheet with you, guys. If you don't have a formula sheet with you, yeah, then you might come across some problems here. So let's start. Let's look at the first term here. We have sine 105 degrees, right? So we can use these special angles to make this or to expand this sign here. So let's do it. So if we use special angles, we're gonna write this as sine, then we expand them. Two special angles that we can use here, we can use 60, that's for sure, and then since we have 104, we can add it with 45, right? So this here, guys, required us to expand like this. When you say 60 plus 45, it's gonna give you 105, and then we say minus, and this one here we have sine 15. Also, we need to use these special angles. This time around we have to subtract 45 and 30, right? Now some of you might want to subtract 60 with 45. It's still fine, guys. For this one here, some of you might subtract 60 with 45, still gonna give you 15. It's still fine, right? But I prefer to subtract 45 with 30. Somehow I find it to be simple for me. All right, so as you can see, this one, it requires us, the second step here, it requires us as guys to use the compound angle identities. Like I said, you must have your formula sheet there. If you look very close on your formula sheet, we have compound angle identities there, guys, right? So you have to expand these two. So let's expand it. Now, if you look on your formula sheet, when you expand sine, it's gonna be sine. Oh, before, let me just show you here. If you have sine A plus sine B, as you can see there, when you expand, this is gonna be sine A multiplied by cos B. Since we have plus here, it's gonna be plus sine B multiplied by cos A, right? That thing or that formula is there on the formula sheet, guys. Don't stress too much about it. If you don't have a formula sheet, make sure that you have it with you, guys, or you can go online and download it. All right, so let's expand this. So this is gonna be sine 60, right, multiplied by cos 45, right? And then since we have plus there, we're gonna have plus between this expansion. So again, we're gonna have sine 45 this time around multiplied by cos 60, right? Are we still together, people? Are we doing the right thing? Can you guys see them? Can you guys see on your phones or on your laptops or TV? Can you see the writing there, guys, before I even uh, start to do this? Oh, some of you don't have formula sheet. Causa. Causa. You need to... Guys, if you don't have a formula sheet, I cannot display a formula sheet here, guys. That will be moving a lot and that will chow our time. But do you have a previous question paper? You can take the old previous question paper, or you can download any N4 previous question paper and just go to the formula sheet. Majority of the students, they have the app that has previous question paper. I assume you have it, Koza. Please, can you uh, can you go online and download any N4 question paper and just scroll to the previous question, to the formula sheet, or you can go to your stationery, to your bag. If you are part of full-time student, I gave you guys previous question papers, right? So I forgot to tell you this, guys. When we start to when we do trigonometry, the formula sheet must be very, very close to you, guys, right? Because I hope you can manage to get the formula sheet. But I'll try to write the expansion of the sign there. So this here, let me highlight with red so that you can able to see this one that is red here, guys. I'm gonna highlight it here. It's for this one. It's expansion of this one here. Now let's expand this one. Let's not forget we need to expand this one. Since we have the negative sign there, guys, we rather put it inside the bracket, right? So I'm gonna put it inside the bracket. When I'm expanding it, I must make sure that I put it inside the bracket. So we're gonna have minus. Now we expand this one. Now, if you can see between 45 and 30, this one here, we have the negative sign there. So when you expand this one, it's gonna be sine 30 degrees multiplied by cos, oh sorry guys, it's gonna be sine 45 degrees, sine 45 degrees multiplied by cos 30 degrees minus, because we have minus in between them. And then this time around we're gonna have sine 30 multiplied by cos 45. Again, if you have a formula sheet, you will see that this is there. I always tell people that you must able to know the signs in the middle, because the formula sheet is gonna give you in a manner of a plus or minus b, and then when they expand, they're gonna give you cos they're gonna give you sine a multiplied by cos b plus or minus, right? And then sine b cos a. So what you should know here, guys, is that you must know how or when is it gonna be positive. So when it's positive here, this one must be positive, and when it's negative there between a and b, there must be negative for sine, right? This is for you, causa, by the way, if just in case, because you said you don't have the formula sheet, so this is for you, right? But try to find the formula sheet, because hey, if you don't have a formula sheet with you, this part of the trigonometry, or this part of the question is gonna mess you up, my man. Right, so let's expand this. So when we expand this, let me erase there. Oh, I already expanded. It's gonna be sine 45 multiplied by cos 30 minus, since we have minus in the middle there, guys, and then we're gonna have sine 30, and then let me just create a little bit of space here, guys. People say they can see, nice. If you guys can see, that's good. And then we have a cos 45. Did we expand in the correct way? Let me see. Yes, we did. Yes, we did, guys. Right. So I'm highlighting this so that you can see that this one here is an expansion of the second term there. And as you can see, this negative it's outside the bracket. We put it inside the bracket because when you multiply by negative them, they're gonna change now. They're gonna become positive, especially the other one that is negative. Right. Now let's use the triangles, guys. Let's use the triangle. As you can see, this one here, it's sine 60. Now remember, sine, it's, let me just say sine theta is opposite over hypotenuse, right? Guys, you really need to know the trigonometric ratios, guys. You really need to know this. So when you look at 60, your 60 is your reference. So what is the opposite? Here's our 60, by the way. What is the opposite of 60? It's root 3, right? So we're gonna write root 3 there, divide by, and then what is our hypotenuse for this 60? It's 2 there. So divided by 2. So we are done with the first one. Now let's look at the second one. We have cos 45 there, right? I'm doing a dot on top of it so that you can able to see. So cos 45, you're gonna pay attention to this triangle. Here's our 45 here. But what is cos? We know that cos theta, it's adjacent over hypotenuse, guys, right? So adjacent, what is an adjacent of 45? Is this one here, guys? Do you guys see? It depends. You can even use this sign here, the adjacent. I mean, you can use this 45 here. The adjacent of this 45 is still the one there, guys, right? Hey, I hope you can see, people. So adjacent is gonna be, oh, let me just go back a bit, guys. Oh yeah. All right, adjacent is gonna be 45. It's gonna be 1, right? And then over hypotenuse, so our hypotenuse is gonna be root 2 there. Remember, we use this triangle there, my people. Do not forget. So divided by root 2. Then we say plus. We have plus there, guys. Do you guys see? We say plus. Let me erase these dots here so that we don't get confused, because these dots, they can confuse us, right? Right. Right. Are we still together, people? Are you still together? Right. So we come to sine 45. Again, sine 45, we know that sine is opposite over hypotenuse. So the opposite of 45, as you can see, this 45, it is this one here. Do you guys see? Or that one. This one is the opposite of this one, of this 45, while the other one, this one here, is the opposite of this 45, guys. Then so we're gonna write 1 over, and then our hypotenuse for this one is gonna be root 2. I hope you guys can see. Really, this is where most people struggle with trigonometry, and these are the basics, people. Make sure you know them. Make sure you know them. Right, multiply by cos 60. This one here, guys. Right, this is cos 60. Now, cos 60, we know that cos is adjacent over hypotenuse there, right? So, what is the adjacent of 60? Here's our 60 there. It's 1. Do you guys see? So, adjacent over hypotenuse. So, our hypotenuse is going to be 2 there, guys. Do you guys see? All right. So far, so good. So far, so good. Can you comment there, guys, if you are still with me? Because I don't want to move very quickly and people get lost there, guys. Right? I don't want to move very quickly and people get lost there. We want to move together. So far, so good. Yes. Are we still together, guys? All right. We have minus there. I am going to stop here until you guys respond there. People respond that you still together. Are we still together? These people are quiet. Say something, my good people. Respond. All right. No one says nothing. It means everything is fine. So far, so good, people. Yes. Are you guys there or are you sleeping? Oh, yes. Tabani say yes. Don't sleep on me, people. You can't sleep on me. I am awake because of you. You know, we're still together. Thank you. Thank you. Yankuna, Loliwe, and Velase, they say yes. Ningalali lapo. We are good. Yes, Kobe. I can see. Don't sleep. Lali. Drink coffee. Drink your Bioplus or energy drink. But don't overdo it because tomorrow you won't be up. Right, we're gonna continue, guys. Well, we're gonna continue. We remove Belas. What are you saying? You are sobering. You're absorbing. Okay, that's good. That's good, man. That's good. Right, let's continue. I'm continuing now. Everything is fine. Now let's look at this part here, guys. Do you guys see this part? Now we have the minus, but we're gonna deal with the part where we are inside the bracket. So sine 45 we just established earlier on, it's 1 over root 2, guys, right? And then cos 30. Now we must look at our triangle. So we're gonna look at this triangle here, guys, right? Cos 30, remember cos is adjacent over hypotenuse. So what is our adjacent for 30? It's gonna be root 3. Do you guys see? Right? And then we want to write root 3 there, right? But our hypotenuse, it's gonna be 2 there. There we go. Right? I'll try to be quick, guys. I'll try to be quick. Last time we were quicker, the mic never died on us, right? And then let's not forget we have this minus here. Do you guys see this minus? Right, so we say minus them. And then we say sine 30. What is sine? Sine is opposite over hypotenuse there. So sine 30, when we look at our triangle here, here's our 30 there, guys, right? Sine is opposite. Our opposite is 1. There we go. Over hypotenuse. Our hypotenuse is gonna be 2. Right. Oh, let's do this. Right. Let me just erase here, guys. I'm trying to erase. I don't want to have a lot of things here on our work here. And then multiply by cos 45. We established earlier that cos 45 is 1 over root 2. There we go, people. There we go. Don't forget the brackets are very, very 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 important, because everything inside the bracket there, it's multiplied by that negative. So I'm gonna highlight there, guys. Track the colors. The colors is to help you guys to track this question here. But please don't do the colors when you're writing the test. We don't like that. Okay, this is to help you to track how we are doing this. Okay, all right. So let's continue. Okay, someone said you are responding. It takes time to appear. All right, all right, Tabani, I can see that. I can see that. I will give you some time. But anyway, let's continue. Now, let's look at these. Do you see these ones here? As you can see, they are multiplying each other, guys, right? They are multiplying each other. So we're going to start with root 3 multiplied by 1. So this is going to give us root 3. And then underneath there, we're going to have this 2 multiplied by root 2. And that is going to give us 2 root 2 there. And then we have to go to this plus there, right? And we say plus, right? And then we look at these ones first, because they are also multiplying each other, right? And then as you can see on the numerator, we have 1 multiplied by 1, and that is going to give us 1, right? Divide by root 2 multiplied by 2, that is going to give us 2 root 2, right? All right. Now, this negative, please don't remove it, because we're still inside the bracket. We do similar with what we did here. So inside the bracket, we have 1 multiplied by root 3 on the numerator there. So 1 multiplied by root 3 is going to give us root 3. And then on the denominator, we have root 2 multiplied by root 2 there. And we're going to have 2 root 2. Right. Minus, we have this minus here inside the bracket. And then we have 1 multiplied by 1. And we have 1 over root 2 over root 2 multiplied by, 2 multiplied by root 2. That is going to give us 2 root 2 inside the bracket. You guys see? Now, we are moving, guys. We are moving. So, as you can see, this one here, the denominator is root 2. It's 2 root 2, guys, right? It's the same. So, the numerator, they must just add. So, you can write it like this. Underneath here, you can put only one denominator. 2 root 2, there we go. And then on the numerator, we can write root 3 plus 1. Do you guys see? Minus, right? Now, this time around, you can multiply by the minus, guys. It's fine, okay? Let's multiply by the minus to remove the bracket. But you can always do the very same thing. Or let's do this. Let us not multiply by the minus. Let's leave it for now. Let's just leave it. So let's say we have the following. We do the very same thing. Inside the bracket, we see these, they have the same denominator, which is 2 root 2. So we can write 2. Oh, let me just create space, guys. Running out of space. Let's create space. 2 root 2, right? And then we have the numerator. We have root 3 and minus 3. So they're going to subtract each other. Let's just say root 3 minus 1, right? Okay, so from here, let's just remove the brackets, guys. Let's remove the brackets. So this one here, we're just gonna rewrite it as it is. There we go. Root 2 root 2. And then when you remove the bracket, root 3 becomes negative and 1 becomes positive. All this is divided by 2 root 2. Okay, let me just move a bit, guys. We're still together. I like the fact that we're still together. All right, so let me create the space there. Now, same thing here. Look at these terms. They both have the same denominator, guys. So meaning the numerators, they can subtract and add each other. Do you guys see? So let's continue. So let me just first write the denominator, which is 2 root 2. And then we can say root 3 plus 1 minus root 3 plus 1. Now, look at what we have here, guys, right? We have the like terms. We have root 3 minus root 3, and we also have 1 plus 1. So, meaning, if we continue here, root 3 and root 3, they will cancel each other. We're left with 0. 1 plus 1, they're going to give us 2. Divide by our denominator, which is 2 root 2. but this 2 and that 2, they will divide each other. What is it that you left with them? Oh, let me just continue with creating space, guys. Then you're gonna be left with what there, guys? Let's create more space, more space, more space, more space. You're gonna be left with 1 over root 2. You guys see? All right, so if we say rationalize, you just multiply by root 2 divided by root 2. That's it. And then when you multiply 1 with that root 2, you're gonna have root 2. Do you guys see? And then if you multiply root 2 multiplied by root 2, guys, you can take this and put it in your calculator. Root 2 multiplied by root 2 is gonna give you 2. So the answer here is actually 1 over root 2. This is also an answer, right? If we never mention rationalizing, this 1 over root 2 is also an answer. If you say rationalize, then you must multiply by root 2 over root 2, and then we have root 2 over 2. Do you guys see? I hope you guys can able to understand. Is there anyone who needs to clarification here? Is there anyone who's lost before we move to the next question? Because this was basically not that difficult. We never even touched the calculator when we're doing this, guys, right? We never even touched the calculator. So you can take your calculator, right, and plug in these here, guys. You can take your calculator and plug in these ones here, right, to check if your answer is gonna give you root 2 over 2, to double check, right? So since your response take time to appear, I'm gonna ask them, is there anyone who has a question concerning this problem that we just solved here? Anyone? All right. If we do not have questions, we're gonna continue, guys. Right? We're gonna continue. And don't sleep, guys. Don't sleep. There's no time for sleeping. No time for sleeping. We are doing trigonometry. After here, I would say sleep, man. You need time for your brain to to relax. Okay, don't overwhelm your brain. Understood. Thank you, Nkona. Guys, if you understood, please also write understood. If you didn't understand, mention the part where you didn't understand, right? It's better to do that. I'm erasing the, since Nkona said he understood, right? I assume everyone understood, right? Right, so I'm erasing. We are done with that question here, guys. Let's check the other question. So I'm gonna zoom again so that we can able to see the next question, guys, right? So let's move to the next question. I'll try to be quick, guys. Our mic is the one that is pushing us. So let's look at understood. Thank you, guys. Keep on saying, keep on responding, guys, whether you understood or not, right? Respond was very important for me to know that you guys understood or not, right? Thank you, guys. Thank you. Who's this? Tabane, Charlie, and Kuna, they understood, right? Let's look at 2.1.2. Prove the following. So now you are given the left hand side and the right hand side. I don't remember doing this on the previous questions here, right? So let's do it, guys. So this one, when you look at this problem here, let me just create a space, people. Create some space very quickly. I'll try to be quick, guys. If you have your books with you, make sure that you go to page 236 and 237. That is where we're gonna use a lot of these identities that you see here, guys, right? So we have the following. We are given sine 2x, right, minus tan x, divide by cos 2x, right? And all this is equaling to tan x, right? Whenever, guys, whenever you're proving whether the left hand side is equaling to the right hand side, make sure that you always, oh, our network, are we still together, people? Our network. All right, let me start over because I saw something that indicates network disturbance. Guys, whenever you prove whether the left hand side is equaling to the right hand side, make sure that you always choose the most complicated side. In this case, our complicated side is our left hand side, guys. Here, this one, left hand side, the one that is complicated. You have to choose it so that it can be equaling to tan x. Guys, I had a network disturbance. Are we still together? Are we still together on this stream of ours? Are we still together? All right, we are. We are. I can see that. All right, people. So now, if you go to page 236 or page 237, you will have double angle identities there. As you can see, look at these two here, guys, right? Look at these two. We have this one there, we have the other one there, guys, right? These two are double angle identities, so you have to change them. At some point you have to change them, so you have to take the most complicated side. So let's change our let's change our double angle identities, guys, right? Let's change them. So let's start with the first one here. This is gonna be if you still remember, this is gonna be 2 sine x, right, multiplied by cos x, right, minus, I would say, people, change this into sine x divided by cos, right? It makes life easier, right? Instead of let me do this. Put this inside the bracket. Instead of writing this line here, do you see this line here, this long line? Rather write it as division, guys, right? Yesterday, Mr. Nkuna showed us the shortest method. I hope this time around I'm not also creating the longest method as well. All right. So I would also say here, do the following. Now, this one is tricky, guys. How are you going to change it? It's very, very tricky. But I would say change it into, yes, this one, guys. Let's see. Let's change it into, for now, let's change it into uh 2 cos x minus 1. Some of you might decide to change it into, remember, the double angle for cos, it has 3, guys. Then it has the following. It has x squared minus sine squared. Sine squared x, right? It has this, and it also has this one, 2 cos squared x minus 1, and it also has minus 1 2 sine squared x. So this one is tricky, so I'm deciding to change it this way, right? There's no reason why I choose this out of this, but I'm going with my intuitions here, guys, right? Right. So let's look at what we have inside the bracket there. Now we have divided by 1 there, guys, right? So we need to find our LCD inside the bracket. So since our LCD is going to be cos, so we put cos there. We say 1, this one here, dividing our cos there. What is our answer? Our answer is going to be cos multiplied by 2 sine x cos. So meaning cos multiplying 2 sine x cos, we're going to have 2 sine x cos squared x, right? Ooh, I hope this is going to work, right? I think it's going to work already. I can see that it's going to work. Now we say minus, right? I hope you can understand this part, people. Make sure that you understand. This time around, we say cos, this cos here, in fact, divide by our cos there. It's going to give us 1. That 1 we multiply with our numerator, which is negative sine. So our answer here is going to be sine x. You guys see? Right. Divide by 2 cos x minus 1. Do you guys see? Right. Let's continue, guys. Let's continue. Now, let's look at the numerator here, guys. Do you see what we have here, guys? We have a common factor here, guys. Do you guys see? On this numerator here, we have a common factor. Our common factor here, if you can pay attention, is sine. So if you can take out sine on this one, we have to take out sine, almost say 2. Take out sine x, right? We'll be left with cos, 2, by the way, 2. Left with 2 cos squared x minus On the other side, you're going to be left with 1. Divide by cos x. You guys see? Oh yes, oh yes, oh yes. Oh yes, this is correct, guys. Right. So divide by, don't forget we have this division here, 2 cos x minus 1. So far we're still okay, people? I hope we're still okay. Right. Now, if we continue, look, if we look at this, guys, we have cos, we have sine divided by cos. What is sine divided by cos, guys? What is sine divided by cos? It's a square identity. I mean, it's a quotient identity. Sine divided by cos x is equaling to tan, right? There we go. So we're gonna rewrite this as tan x. There you guys see. But let us not forget, we still multiply by 2. Oh yeah. Oh, I forgot to put squared here, guys. You guys see? Oh, I forgot to put squared here. When I change this, I forgot to put squared. Guys, I forgot to put squared here. You guys see? Please remember, this here is the same as that one there, guys. Right? I forgot to put square. Be very careful before we get lost. Right? I forgot to put square. Are we still together? I hope you're not confused, people. Right? I hope you're not confused. So let us not forget, after writing tan, we have 2 cos squared minus, or 2 cos x, what is it? 2 cos squared x minus 1. There we go. And then instead of writing divide, we can say multiply, right? Remember, if we change this division into multiplication, what happens here? The numerator becomes a denominator and the denominator becomes a numerator. So here our numerator is actually 1, guys, right? So it's gonna be 1 divided by 2 cos squared x minus 1. You guys see? All right. Now you can multiply. Oh, our numerator here is 1 as well, guys. So you can multiply the denominators and the numerators. So if you say tan, if you multiply all this, right, with this one here, it's gonna be exactly that. It's gonna be tan x multiplied by 2 cos squared x minus 1. Divide by, now if you multiply this one with that, remember we have the multiplication here, guys, right? We're gonna have 2 cos squared x minus 1. You guys see? Right, guys, I hope you can still follow. I hope you can still follow. Now look, this 2 cos squared minus 1 is gonna divide with the one on the numerator. So what is it that we left with them? We left with tan x. So therefore our right hand side is equaling to our left hand side. Let me just zoom down a bit, guys. Remember the answer there, it says our answer is our right hand side here is tan. You guys see? So as you can see, this is equaling to tan there. I hope you guys managed to do this one. It was long since yesterday I took the long route, guys. I assume there's a shorter route. Lawrence, are you seeing any shorter route, man? Because yesterday you saw the shortest method of simplifying. Is there any shorter method that you are thinking of, Mr. Lawrence? Yesterday you saved us a lot of time, right? Or anyone else, not only just Lawrence. Anyone else? Do you have a shorter method? Do you see any shorter method there? All right, people. I assume we understood this question. Yes or no? Please write understood if you did. And if you did not understand, uh, leave your question so that we can able to answer it, guys. Our mic is about to die, but I think if we can solve for x, we'll be able to we'll be fine, man. Even if it dies after the simplification, we will be okay. Before the simplification, we'll be fine. The highlighted part, how do you get that part? Are you talking about sine over? Oh yes. All right. Now I get. Tabane. Oh, let me zoom. Let me zoom in. Let me zoom a bit. Let me zoom a bit for you, Tabane. Tabane, let's look at. I'm gonna use the red color so that you can be able to see. Tabane, let's look at this term here, right? Let's just look at this term here. I'm highlighting it now. Look, we have minus. It means this. In fact, it's not a term. This numerator here, right? We have a minus there. Do you see that minus there? Yes. That minus, it means that we have two terms. Now, this term, the first one here, it has sign. Do you see? And then the second term, it also has sign. So we took out the common factor. If we take out this common factor here, we're gonna have sign there, and then we're gonna be left with only cos squared x, which is 2. This 2 here, 2 cos squared x, which is this one, right? If you take out sine out, and then on the second term, if we take out sine x out, we're gonna only be left with 1, right? I hope you understood, Taban. And then underneath here, we are divided by this cos x. So this cos x is this one here, Taban. Did you understand now? Because I think that's what you meant when you say the highlighted part you didn't understand. Did you understand, Taban? Guys, make sure that you write understood, guys, or you ask a question. It's very important. Do not forget that, right? I can see Nakumba understood. Who else? People? Who else? Who has questions? So I'm gonna give you some few minutes so that you can. Loud and clear, Taban. Thank you, sir. You are welcome. Guys, why are you all quiet? There are 33 people here. Say something, people. Say something. Don't sleep. I told you don't sleep. Drink some coffee or some energy drink now. Don't sleep on me, people. All right. Understood. Thank you, Tally. Thank you. I'm erasing now. I assume everyone understood. Guys, if you don't say anything, I'm going to erase here and I'm going to pass this point and then you guys will be lost. Understood? Thank you, Mr. Nkuna. Right? Who else? Right? Magagula. It's been a while since you commented, Miss Magagula, but I'm glad you understood. Right? Is this? Yeah. Senzo understood. Thank you, Senzo. Thank you. So, meaning we're moving to the next question, guys. We are solving for x. Ooh, let's see. Now we have this question here, guys. Let me zoom it very quickly. I think I've done this in class, but anyway, I hope this time we're gonna understand it better. Now we have question 2.1.3, guys. There, they want us to solve for x, and they give us the domain, guys. Whenever they give us the domain, they say x should be between 0 to 360, right? So we can have x here, we can have x here, we can have x there, we can also have x there, because this is 90, this is 180, this is 270 degrees. So whenever you're given a domain 0 to 360, it means you can have x on every one of this. So we are given this equation here. So this equation here, it's already simplified, but not really, guys. Not really. We need to change this. We need to change these, guys, into what is this? Same trigonometric ratios, guys. Right? So let me just write it. I'm gonna need. Oh, guys, I think I'm gonna need a book myself here. I'm gonna need a formula sheet. I'm not using a formula sheet. I'm also not having a book with me, guys. So yeah, we have to. I think we have to. I have to go to the book or the formula sheet, because in order for us to do this one, guys, if you don't have a formula sheet, please go to page 230, 237, 231. I have to take a book, guys, right? I don't know where is my book. I don't know where I stashed it. Yeah, I sold it. I think I sold it. Oh, here it is. Here it is, guys. Oh, Is this N4, N5? Oh, there we go. This is N4. Guys, go to page 236. I'm heading there myself because this one, it will actually gonna require us to go to that page. If you have a book with you or you have a formula sheet, go to your formula sheet or go to page 236. On page 236, by the way, we have what we call the square identities, guys, right? We have the square identities. I'm going to write the square identities that we're going to use there. On that page, we have 1 plus cot squared x is equaling to cosec square x. Yes, we have something like this. This square identity that I'm highlighting here, we have to use it so that we can have the same trigonometric ratios. Remember from yesterday, I did mention though that whenever you're solving for x, your trigonometric ratios, these ones here, they must be the same. If they are not the same, you must change one. And as you can see here, the one that we need to change here, guys, it's cot. We cannot change cosec because cosec, it does not have square. Basically, when we see a trigonometric ratio that has square, there's a chance that you can change it. So you go to page 236, and then we have what you call square identities there. You look at those square identities and then you change it. So how are you going to change it? Here, we're going to use this square identity. We make cosec subject to formula there. Already cosec, it's already subject to formula there. You guys see? It's already the subject of the formula for this one here, guys. So what you do here, you just change it. So you say 3, wherever there is oh no, I'm sorry, guys, it is not. We need to make cot subject formula. It is not subject formula, guys. We need to transpose this one to the other side. You guys see? All right, so if you say cot squared x is gonna be equaling to what is it? Cosec squared x, and then this one is gonna become -1. You guys see? I hope you guys can see, man. I hope you guys can see. Then wherever there is cot squared on the equation, we're gonna substitute with cosec squared -1. We do have cot squared. Here's our cot squared here. Let me highlight again. Here's our cos squared here, guys. There, here's our cos squared there. So we do have it. So instead of writing cot squared, we're gonna write 3, right? Let me write the line here so that we don't get confused, guys, right? I don't want us to get confused. Oh, all right. I don't know what's happening. Right. So instead of writing cot squared, what are we going to write? We're going to write all this. We're going to write this. We're going to write cosec squared x -1. Right. Right. Our mic is still okay, guys. I'll try to be quicker. And then -4 cosec, right, x. Let's transpose this one to the other side. It's going to become -1. All this is equaling to 0. Right, so we are trying to make this equation here to be a trinomial. Already it is a trinomial, but we're trying to make it to be a trinomial. So we multiply by 3 throughout here. So let me just do this. So if you multiply by 3, this is going to be 3 cosec squared x, but this 3 is going to multiply this -1 inside the bracket there. We're going to have -3 minus 4 cosec x -1. All this is equaling to 0. Then we look for the like terms. We have 3 here and -1. -3 and -1, they're going to give you -4. So if you continue, we're going to have 3 cosec, right, squared x minus 4 cosec, right, minus 4, because -3 minus 1 is going to give us -4. Are we still together, people? You must comment, right? You must comment, because I almost made a mistake and you guys were quiet. You were quiet. Don't keep quiet. You must comment, right? Our mic is still fine, so let's continue. Right, people? Now we have to factorize this again, people. Just like yesterday, you can use the k method. You can say let, I'm not going to do this, but it's another method that you can use. You can say let k equaling to cosec, okay, cosec, right? Right, x. So meaning you can write 3 wherever there is cosec, you're gonna write k, but this one is squared, so you're gonna write squared minus 4 k, because this cosec minus 4, and then you get equaling this to 0. You can use this method, right, if you really can't see them, but I'm not gonna use it because it's too long and we don't have enough time. Our mic is gonna die on us, so you can use that method, guys, right? But I'm not gonna use it. So here we have to factorize, guys, right? Now your factorization, you've been taught since grade 9. So let's see, guys. Right, so the factors of cosec or 3 cosec squared is gonna be 3 cosec and cosec, 3 cosec, right, x and cosec. We don't have any, guys, right? There we go. Right, now we must look for the factors of 4. When you multiply with these two factors, they must give us this negative for them. Now, if we put 2 and 2 there, let's see if it's going to help us. If we say 3 cosec multiplied by 2, this is going to give us 6, right? Cosec, right? Cosec x, right? And then if we say this 2 multiplied by cosec, is going to give us 2 cosec, right? X. Now, what do we have here? We have negative 4 cosec. So we can say this 6 cosec x is negative. If you minus these two, they're going to give us negative 4 cosec x, right? Which is the same as the one here in the middle, guys, right? This is how you do rationalize. This is how you do factorization. If you can't use the quadratic equation, is it equation or formula? Use the quadratic formula, guys, right? Use the quadratic formula. So meaning now we need to know between these brackets which one is going to be negative. So it's the one that is going to multiply this 3 cosec. So it's going to be this negative here. This 2 here is going to be negative because it's multiplying this 3 cosec there, and this one is going to be positive. So far so good, my good people. Okay, I hope you're fine. So from there you can say the first one here, 3 cosec x is equaling to negative 2, and the other one you can write end here, it's cosec x is equaling to positive 2. All right, so what we need to do here is to divide by 3 on this one. So if you divide by 3, this is gonna be 3 is gonna be cosec x, and then we have negative 2 over 3. This one we don't change nothing at the moment, guys, right? We change nothing at the moment. Cosec x is equaling to 2. Now, here's the tricky part, guys. I need you to pay attention. Guys, are you still awake? Are you still awake? Are you still awake or are you sleeping? People, are you still awake or sleeping? Right? You must speak up, people. You must comment there. You must comment so that I can know that I'm not working with sleeping people. Are you awake? These people, they're quiet. They are so quiet. No one says nothing. Okay, it's fine. I am continuing. We up. Thank you, Velase. Hey guys, yeah, you must let me know when you are up. Still awake. All right. Good, Ndaba. Good. Gona. All right. All right. We are. I appreciate that, guys. So let's go back. Cosec, right? Let me explain this. Cosec. This is cosec theta. We know that cosec is the same as 1 over sine theta, right? So you can write this in this manner. I don't like, really, what I don't like people when they substitute this, right? Like this. Rather say, oh, so if sine theta, let me try to explain. It's y over r, then cosec theta, right? It's r over y. We all agree there, guys, right? We all agree. So you have to change this cosec, guys, into its inverse. right? Because we have to calculate the reference angles here, guys, right? So we can't calculate the reference angles here if we have cosec, because we don't have cosec in our calculator. So in order for us to do this, we can write this like that, guys. Let me show you. You can write it like this. You can say, to save time, you can say sine x, which is the inverse of cosec, right? You can say 3 negative 3 over 2, right? And this one is the division of 1 there. And then you can say, and sine x on this one, it's 1 over 2. Basically what you do, you swap these, guys, right? You swap this, but you change the trigonometric ratio into its inverse. You see, you swipe this, you swipe that, right? And then you change this into its inverse. Okay, someone asked a question, which is Sibuyane. When I use the quad formula, I get 3 over 2 and negative 2, but you got positive 2. Say which? Oh, let's double check Sibuyane, right? Let's double check, guys. Let's double check. Sibuyane says the signs are not working out. Sibuyane, yes. Here's how am I going to double check. Here's how am I going to double check. I'm gonna write this here. I have 3, right? Cos sec x plus 2, right? Multiply by cos sec x minus 2. There we go, right? Right. Okay, so let me do FOIL. If I multiply this cosec with this cosec, we're gonna have 3 cosec squared x, right? Right. If I multiply this 3 cosec with that 2, we're gonna have minus 6 cosec x, right? Because I multiply this one with the 2 there, right? And then if I multiply this 2 with this cosec here, we're gonna have plus 2. Oh, let me just create space. And I hope you're paying attention, man, because now you made me do extra step. We're gonna have 2, right? Cosec x there, right? And if I multiply this 2 with that 2, we're gonna have minus 4, right? Okay, so we know that this 3 cosec squared x is gonna remain like that. But look at this, we have negative cosec, right? And that positive cosec. These are like terms, guys, right? When they subtract, what is it that they're gonna give you? They're gonna give you negative 4 cosec x, right? Right, because they will subtract each other, and then minus 4 there, right? If you can look at this, Sibuyane, it's the same as what we have there, my man. So double check your quadratic formula there, my good man. Please double check. I think you made a mistake somewhere. I really can't tell where, because I can't see your work at the moment, right? So double check, Sibuyane. Right, I am moving on, right? Double check your work, Mr. Sibuyane. Now I was explaining this part here, guys, right? I was explaining this part where I say you can change this trigonometric ratio to its inverse, which is sine x. But when you change that, these negative 2 over 3, they're gonna swap, guys. It's gonna be 3 over negative 3 over 2 for this one here. And then also when you change the trigonometric ratio to its inverse from cosec to sine, it's gonna be, remember it was cosec 2 over 1. Now it's gonna be 1 over 2 if you change it into sine. Guys, you don't really have to make your life difficult. You just need to know the inverses, guys, right? The reason why we do this again is because we don't have cosec on a calculator, so we can't calculate the reference angles here, guys. Do you understand? So make sure that you change it into trigonometric ratios that we have on our calculator. So on our calculator, we have sine, we have cos, and we also have tan. If we have the inverses of this, which is cosec for this one, which is sec for this one, and which is cot for this one. You need to do what I just showed you there, guys, right? Just swap the the x and y there, right? So let's continue. Now remember this one here, let's look at this one first. Let's look at this one. This one here, it says we must find x when where sign is negative, guys, right? Where sign is negative. You guys see? So we know that on our cast diagram, let me just write it very quickly here. On our cast diagram, I'm gonna do it here, guys, right? On our cast diagram, sign is negative where? On the third and the fourth, right? Sign is negative there, meaning we need to find the reference angle here, and then that reference angle we're gonna add it with 180, and also we're gonna minus it with 360, right? So let's do it. Remember, when you find the reference angle, we never include the negative there. Do not forget, guys, the reference angle is an acute angle. I always tell people this and people get lost there, right? So let's do it. So you're gonna write sine x is equal to 3 over 2, and then it's going to be sine, it's going to be x is equal to arc sine 3 over 2. And then what do we get then? What is arc sine 3 over 2, guys? So I'm going to take my calculator. Arc sine 3 over 2. Here we go. It's an error. So if it's an error, we do not have the angle here, guys. So you leave it like that, right? Now we come to this one here. So look at the answer there. Our half is positive. Do you guys see? Our half is positive. It means now we need to find x where sign is positive. So sign is positive on the first quadrant and also on the second quadrant. Do you guys see? Right. So meaning our reference angle here is gonna be the angle that belongs on the first quadrant. So the reference angle for this one here, guys, is gonna be an acute angle, by the way, and it's positive, so there's no need for us to change it. So we're gonna write there x is equal to arc sine half, right? So this is our reference angle, but at the same time, it is our angle that belongs to the first quadrant. Are we still together, people? Are we still together? I'm worried my mic, I think, is gonna be off very, very soon. I just have that feeling. But anyway, let's continue. So what is arc sine half? Arc sine half 0.5 is gonna be 30, right? So this is the angle that belongs on the first quadrant, guys, right? So it's an acute angle. So for the first quadrant, we have 30. Remember our domain, it says from 0 to 360 at the beginning. That's what I mentioned there. Now, remember, this one here states that our sign must be positive. I did mention that our sign is positive on the first quadrant and on the second quadrant. So on the second quadrant, how do we represent? We said 180 minus reference. Our reference angle here is the same as the angle that belongs there, guys, right? So for the second quadrant, it's going to be 180. Our x is going to be 180 minus 30, which is going to give us what? 150 degrees. So our answers here, we only have two answers for this one, guys. X is equal to 30 and 150. So this is how you calculate the x on this type of equation. Guys, I think I've done this one in the class. If you're not part of the class, then probably this is the first time you've done this one. Are we fine, people? Do we understand this question? If you don't understand, please comment. Don't keep quiet. Comment. Let me fix my mic. I don't trust this guy, man. It tends to switch off. So I'm keeping on checking him now and then. All right. Are we still together, guys? Any questions? Please don't forget to ask questions. And don't sleep. Do not sleep. Do not sleep. We have 23 people. Nkuna understood, right? We're happy about that. Any questions? Any questions before I erase this, guys? So this is out of 5 marks. While you are writing your questions, let me just show you how we allocate marks here. We're gonna allocate marks for changing this this identity, and then obviously we're gonna allocate marks for factorizing, and then also getting the right factorization, and then these two answers here, guys, right? These two answers, which is 30 and let me close here, and 150. It's out of 5 marks. So make sure that you get these three. Usually people, when they get here, they get lost, guys. They usually get these three. They manage to get to the point where, yeah, we get to this point here. They get there. So that 3 marks, they usually get it, right? They usually get it, right? People say they understand here. I am dead, guys, because yesterday Fatigue was playing games with us. Fatigue was playing games with us. I didn't like Velas, please revise again on sec minus is equaling to minus 3 over 2. I do not understand that part, Velase. I really don't understand what you mean by that. Revise again. Do you want me to explain when you say revise, my man? Isn't it what we are doing now, Velase? Because I say a lot of things here in Velas, but let me just explain here, right? So this is sec x is equaling to 2 negative 2 over 3, right? So I said to you, you must change this sec into sine. The reason why, because we want to able to find. All right, people, I don't know the audio. Is the audio back? Is the audio back? Yeah, our mic back, guys. I'll try to charge it though. I was explaining to Mr. Velase. Can't hear. Still can't hear. Guys, you must hear me now. Can you hear me now? All right. Yeah. But now it's bad, guys. I'm using the mic from the laptop. I'm charging the other one. Mr. Velase, um, I don't know whether you understood the explanation there, man. But the cosec negative 2 over 3, it gave us an error, right? It gave us an error. So we don't continue from there, guys, right? We don't continue from there. Unfortunately, our mic is dead, guys. Shall we continue with the remaining part of our shall we continue with the remaining part of the trigonometry there, or shall we wait for the mic to charge? It might take some time. This question though is very short. I can charge it for 3 minutes and then we continue, because really I need to get a mic, guys. This mic is disappointing me. Yeah, it's disappointing me. Anyway, Anyone with a question? Mr. Velas, are you answered before I continue there? Are you answered them? Are you answered? Are you happy? Are you happy, Mr. Velasi? Yeah, because you asked a question that it was hard for me to understand what exactly you wanted to ask, but I assume you wanted me to revisit the the part where we were doing, where I was explaining the cosec negative 2 over 3. Mr. Velas, I'm waiting on you, my man. Say something. Say something, Mr. Velas. Right, say something. Okay, Charlie said we must continue. You can hear me loud and clear. I just don't like the audio here. We shall continue, Charlie. We shall continue, my good man. Yes, I'm answered. All right, Mr. Mvelas, if you're answered, I'm happy. Guys, let me erase this, right? Let me erase this. I'm glad you guys understood how to solve for x here, because this part here, guys, it's where most people get confused, and I hate the fact that I cannot elaborate it further. But sometimes you guys, you don't practice, man. You see, if you don't practice, guys, this math thing is gonna mess you up, my good people. This math thing is gonna mess you up. Practice, man. Practice, because when you do N5, trigonometry should be something that you are excelling on. You should be excelling on trigonometry, guys. Right? When you do N5, you should excel on trigonometry. So let me just zoom this, and so that we can do the last question, guys. Then we sleep. All right? It's already late. It's 12 o'clock, and you guys are supposed to wake up early and write them, right? So let me just zoom this one. We're gonna be quick about this one. It's very simple, right? I'm hoping Mr. Nkuna can be able to help us to find the shortest method. Right, let's look at 2.1.4 there. It's all about simplifying, guys. We are given tan over 2 x over 2 sine x minus tan. Right, again, guys, you can't do this. Okay, please don't do that. It's not allowed. Please, it is not allowed. We have a negative sign there. You cannot do that. Right, let me just write it on the side, and let's see if we can able to solve it quicker before we leave, before we, 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 we sleep, guys. It's 12 o'clock now, right? Except sugu manje, it's not the right time to be awake. There are people who are dominating these times of night, right? So we have this, guys. So they want us to simplify this problem here, right? So let's try to simplify it. I tried to charge the mic. I think we're able to finish this without a mic being. It's back again. All right, let's try. Right. So let's try to simplify this, guys. So again, the best thing that you can do here, guys, is to change all this. First of all, you change the numerator into sine x over cos x, right? Instead of writing divide the sign here, instead of writing this line here, you write divide like that, right? And then you change this one is a double angle identity. You write 2, let me put this, sine x multiplied by cos x. Guys, go to page 236. You will see these double angle identities. Minus, instead of writing sine, also cos, I mean tan, you write sine x over cos x. There we go. Right. Then the one here, there's nothing you can do at the moment. Just write it as sine over cos x, and then divide by. And then here you have to find the common denominator. All right, the lowest common denominator. This is divided by 1, by the way. So we do the same thing. You say with this one, dividing cos is gonna give you what is it that is gonna give you this thing? It's gonna give you cos. Multiply by 2 sine cos. then you're gonna have 2 sine cos, oh, 2 sine x, by the way, 2 sine x multiplied by cos x, right? And then minus, and then you say this cos here divided by that cos, you're gonna have 1 multiplied by the sine there, and then the answer is gonna be negative sine x. There we go. And then you continue. Here is sine x divided by cos x, right? And then divide there, guys, and then you have the following. Now on the numerator, let me just show you this numerator here. We have the like terms. You guys see, we have the common factor. We have sine x here, we have sine x there. So we take out the common factor. So let's take out the common factor, which is sine x. There we go. If you take out the common factor, we left here with cos x. There we left with 1. You guys see, and this is gonna be divided by let's not forget, this is cos squared. Oh guys, this is cos squared. Remember, if we say 1 dividing cos, it's gonna be cos multiplied by 2 sine cos. So this cos is gonna be cos squared there. I almost forgot that, guys, right? And then divide by, thank you Nakumba, I just realized that, thank you, right, divided by cos x. There we go. You guys see? And then we can say, let me just give you some space again here, guys. We can do this. This is similar to what we did earlier, guys. You see this sine and cos, this is tan, and this is also tan. So we can take it back to tan, guys, right? Let's take it back to tan. Oh, we left 2 here. Thank you. I'm trying to be quicker because the mic is gonna switch off very soon, guys, right? So yes, we have 2 there. Thank you, Mr. Lawrence and Nakumba. I'm trying to be quicker, guys, because the mic is gonna be off. So this is tan. Let's take it back to tan, and then divide by, we have tan, the highlighted part. Then we have 2 cos squared x minus 1. There we go. And then we change this into multiplication. So if you turn this into multiplication, we're gonna have 1 divided by tan x, right? We fix the 2 there. What is it, Mr. Bukaba? Hey, your name, it's kind of hard for me to pronounce it, forgive me. And then x minus 1. So this tan and tan, when they divide each other, you're gonna be left with 1 over 2 cos squared x minus 1. But what is 2 cos x minus 1, guys? What is 2 cos x minus 1? This is a double angle identity. Remember, cos 2x is equaling to 2 cos squared x minus 1. So we can change that into 1 over cos 2x. Do you guys see? But then, what is 1 over cos x? This is going to give us sec x. Do you guys see? So in this case now, it's going to be sec 2x. Final answer. You guys see that? So that is our final answer, guys. Mr. Bukaba and Nkuna and Nakumba, I hope you can see that we fixed those problems. I was in a rush, guys. The mic is gonna die anytime soon. I tried to charge it though, it's gonna die on us, guys. We are done with this trigonometry question. Guys, let's sleep, guys, right? So I wish you all the best tomorrow. As you can see, let me just show you this question paper very quickly. The format, guys, it's similar, right? It's similar. It's just that we're not gonna do other questions. It's similar. Look, the first question is complex numbers. This time around, we decided to make you to multiply the rectangular form, and then we give you the polar form, and it says, but we gave you something like this, whereby you calculate the given complex numbers and live in polar form, meaning you need to able to move from rectangular to polar. And then 1.3, you are solving for x there. And then question 2, we just did question 2. And then question 3, it's limits. This time around we gave you this one here, and the last one, it's similar. You have to use the first principle, guys, right? So right, tomorrow I hope you guys, you'll be ready. All the best, guys. Please pass. As you can see, we worked so hard so that you guys can able to understand better. As for test 2, we're gonna do the same thing for test 2, guys. We're gonna do question by question because of the time and the mic that we have. It's really killing us, guys. Thank you very much, guys, for watching and also being part of this experiment that I was trying. So yeah, man, you can share this to your friends, whether they are attending with us or not, whether they are in different colleges. Please share with them, guys. And if this was really helpful, you can also write there helpful. I can see you guys are saying thank you. Thank you to you too, guys, all of you, for being part of this. Good luck tomorrow, guys. Make sure you arrive early so that you don't get rush. And as you can see, the question paper might seem like it's too long for the time that you'll be given, but if you practice, the time won't be a problem, right? And don't forget your calculators as well, guys, right? It's gonna be 40 marks. It's gonna take 1 hour 12 minutes, right? Thank you, guys. Till tomorrow. uh See you guys tomorrow. Yes, see you. I won't see you, but till next time. Let me just say till next time. Thank you, guys. I am moving out.